All right, what's up, y'all? In this video, I want to talk a little bit about certain types of function transformations. All right, so if you have a function, uh, in this case, we're going to be talking about this function, f of x, or which we'll call the parent function, with f of x equals x squared of parabola. Say you start out with this parent function, f of x equals x squared. Basically, what you can do is you can move the function around um, on the graph by doing certain things to it. So check this out here. So this, okay, f of x equals x squared is our parent function. That's like the function that we start with. So if you do certain things to x, and if you do certain things to f of x, you can move that function around. So let's look at it graphically real quick. So basically, okay, make sure that that glare is not in the way. So basically, f of x equals x squared looks something like this. So when we do certain things, we can move this thing to the left or to the right, and then there are certain things we can do to move it up the y-axis and move it down. Okay, so that's what we're talking about here. And what you focus on whenever you're talking about moving it up, down, left, or right is you look at whatever you're adding or subtracting to x, and then you look at whatever you're adding or subtracting to f of x. Okay, to the whole function. All right, so and we're going to step through all this. Let me use a different marker. So if you want to move the function to the left, what you'll see is you'll add some value, which we're calling h, to x. If you want to move the function to the right, then you want to subtract a value, which we'll call h, from x. Okay. If you want to move the function up, it's when you add k to the function, some value. For k is only just a variable. And if you want to move a function down, you want to subtract k from a variable. So let's look at it so it just makes sense. So it's not just all these numbers and letters being thrown around. All right. So check it out. So say, again, our parent function is x squared. So say we want to, say we have this here. Let's say you have g of x is x plus 1 squared. Okay. Now, yeah, it looks a lot better. Now, so according to our notes here, which I definitely encourage you to like make sure you copy this stuff down in your notes because you want to be able to refer back to it. According to this, if we add anything to the x, then it's going to move the function to the left. So let's actually graph it. All right, so I like to create a list of coordinates. So you have x and f of x. So I'm just going to plug in values for x and see what it gives me as a f of x value or y value, and then we're going to plot it. All right, so if x was 0, 0 plus 1 is 1, 1 squared is 1, so x is 0, f of x is 1. If x is 1, 1 plus 1 is 2, and then 2 squared is 4. Okay, yeah. And then if x is 2, 2 plus, so x is 2, 2 plus 1 is 3, and 3 squared is 9. Okay, I don't have a lot of space on this board, so we'll just go no higher than 2. So let's go back in the negative direction. If x is negative 1, then negative 1 plus 1 is 0, and then 0 squared is 0. if x is negative 2 plus 1 is negative, okay, negative 2. Negative 2 plus 1 is negative 1, and then negative 1 squared is 1. All right, so let's plot. This is not a whole lot of points, but let's plot it and see if indeed adding a value to x moves the whole function to the left. All right, so let's plot that. Negative 1, negative 2, and 1 and 2. And then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so when x is 0, f of x is equal to 1. This is the x-axis, and this is the y-axis, or I mean, not f of x, g of x in this case, or g of x. I'm sorry, I drew that, I put the wrong letter there. All right, and then when x is equal to 1, g of x is equal to 4, 1, 2, 3, 4. When x is equal to 2, then g of x is equal to 9, which is all the way up here. All right, going back the other way, when x is negative 1, y is 0, x is negative 2, y is equal to 1. All right, so, it probably would have helped for me to go at least to negative 3 so I could show you the full whatever. But this is basically how your function looks here. So if you see the vertex of this parabola is moved to the left. So indeed, when you add to x, you see that it actually moves this function left, okay? So you can already know if you subtracted 1 from there, then the vertex of this parabola would be at 1. You see? So this helps you to see that this works. So that's why it's important for you to make sure that you have your notes handy so you can kind of know, because if you graph it, you'll be able to see indeed that to move left or right, you have to add or subtract to x. Now let's look at an example of trying to move this function up or down. So say that we had, and I'm just going to use some of the same stuff here. So again, our parent function, f of x, is x squared. Again, parent function is just a function that we're starting with, but this applies to any function, x squared, x cubed, whatever. All right, so say that g of x was equal to x squared plus 1. So now we are not just adding, we're not adding to the x, we're adding to the function. So f of x equals x squared, g of x is essentially f of x plus 1, x squared plus 1, okay? Let's see what values we get, and then we'll plot it and see if it indeed moves. According to our notes, if you want to move the whole function up, you have to add some value to f of x. So this should move the whole function up. All right, so when x is 0, 0 squared is 0 plus 1 is 1. X is 1. 1 squared is 1 plus 1 is 2. When x is 2, 2 squared is 4 plus 1 is 5. Let's go back in the other direction. When x is negative 1, negative 1 squared is 1 plus 1 is 2. When x is negative 2, negative 2 squared is 4 plus 1 is 5. That should be enough. And so you should already be able to see, okay, well, there is no point that's at the origin, 0, 0. So you can already tell, looking at your g of x values, that this must be up. So let's just plot it so you can actually see it. All right. All right. All right, so when x is 0, y is equal to 1. When x is 1, y is equal to 2. When x is 2, y is equal to 5. All right, when x is negative 1, y is equal to 2. When x is negative 2, y is equal to 5. All right, so our graph goes through these points and looks something like this. And as you can see, yes, indeed, when you add to the function, you move your function up. You move your parent function up. So you can already know that if we had subtracted 1 from this function, then it would have moved this down, moved this vertex, this bottom point, down to -1. So this would have actually been below the x-axis. So yeah, so there you have it. When you want to move a function left, right, up, or down, this is the key. To move left, add to x. To move right, subtract from x. To move up, add to f of x. To move down, subtract from f of x, okay? Very straightforward, very simple. In another video, I'll talk about these other variables here, a and b, and what those do. All right.